Good afternoon, everybody. Welcome to the Lights Out for Birds webinar. Thank you all for joining us today. I'm your host, Savannah Jordan, and I'm a wildlife biologist with the South Carolina Wildlife Federation. I coordinate many of our different habitat and education programs for our organization, but birds in particular are very near and dear to my heart. So I'm so happy to be here with some other fellow bird nerds. Our speakers today are Jennifer Tyrell. She's the engagement manager for the South Carolina Audubon. Jake Heck, he is our industry habitat manager, also with the South Carolina Wildlife Federation. And Amy Tegler, South Carolina Department of Natural Resources Bird Conservation Coordinator. So they're going to be talking all about the dangers that birds face during migration, the issues of light pollution for wildlife, and the steps that we can all take to protect birds and wildlife. So if you have any questions during this webinar, just please type them in the question box and include which speaker your question is for. And we'll answer as many questions as we can after the speakers present. So with that, we'll start with Jen. Take it away, Jen.
All right. Well, thank you guys for having me, and thank you for joining everyone. Looks like we've got 11 participants so far, and I think a few more are going to come filing in. But if you want to go ahead and move forward, Savannah, on the slides. I think there's a picture of me, but you can also see me in your camera, so it's a little redundant. Except my hair is about a foot shorter back then. That was pre-COVID. I am holding one of my favorite birds. A lot of people think painted bunting must be my favorite, but I prefer the indigo. I just think they're really pretty. All right, if we want to go ahead and get started on the next slide, I'm going to be talking to you mostly about bird migration, and we'll get into some of the hazards of migration, how migration works, and then we're going to be moving into how, oh, sorry, that phone went off, how that kind of impacts, oops, I think we lost the slideshow here. And we're going to talk about what hazards birds face and how light impacts bird migration and a lot of other things. So we'll start here with the birds only information. Next slide, please. There we go. So this is a really cool animation that is kind of like a preview from the Bird Migration Explorer, which we're going to see a little bit more from in a minute here. But each dot represents kind of like the collective movement of a species. And so these are all species that have been tracked either through satellite tags, through eBird and community science information, reporting your bird sightings, and then also I think the geolocators and nano tags through the MODIS network, all those things combined to this really cool one-stop shop of migration information. So you can see birds move across our hemisphere all generally around the same time. And you can tell there are some areas where a lot of species will funnel through together, making it really high traffic areas for migration. And those are some of the more dangerous places that they travel through. All right, I could just be mesmerized like that all day, but we're going to talk about why birds migrate. So this poor little hummingbird obviously decided to stick around during the winter time. Many of our bird species eat insects. 90% of land birds eat insects to feed their chicks, and then also to get protein sources. So even things like cardinals and chickadees, they eat a lot of insects, caterpillars mostly. And during our winter time here in North America, we don't usually have a lot of insects. So a lot of them pack up, go south for the winter to avoid weather like this, like that poor little hummingbird. All right, next. Insects, like I mentioned before, this is a prothonotary warbler. They are a neotropical migrant, which means they go to Central and South America. We have a lot of these at Beidler Forest, and it's one of the birds I personally study with Audubon. This guy has a spider and a caterpillar, or two caterpillars in its beak, and it lives in the swamps, eats tons of bugs, and then through some tracking information and research that we've done, we found out almost all the prothonotary warblers in North America all hang out together in the winter in Colombia, South America. So it's pretty incredible the journey that they make. We don't know too many details about how exactly they get there, when exactly they're leaving, what their stopover locations are. But this spring, we're going to be working on that. We're going to put on cutting edge technology trackers on them to hopefully find out a lot more detailed information. So that's really exciting and coming up. So stay tuned for that talk later on. All right, next one. This is the Bird Migration Explorer that Audubon and a bunch of partners you can see listed at the bottom there have put together. And it's a really incredible website. Only get on there if you've got some time because you can get, go down rabbit holes checking out all the different information. You can look at each bird species, specific tracked individuals. And what you see there is highlighted one track of an osprey, but each of those tiny, faint little lines is one individual bird that's been tracked. So you can get all sorts of cool information. And then you also can look at the threats that they face in their journey. And then also look at connections. So you can click on a bird that's been spotted in Colombia, South America, and then see all the other places that individual has been tracked and picked up through the MODIS network or, other means or banding stations. So really, really cool. A great way to learn a lot more about migration and the issues that birds face. Next. All right, so first we're going to talk about raptors. Raptors have some interesting ways that they migrate. The big thing about them, though, to keep in mind is that they migrate during the day. So a lot of our other birds actually migrate at night, and it's to avoid them because raptors eat birds, especially like Cooper's hawks and sharp-shinned hawks, merlins, American kestrels. They'll eat songbirds, no problem. So they migrate during the day. All the songbirds avoid them and migrate at night. Next slide. So how hawks and other raptors like to migrate is by using like a free ride. They find thermals or rising columns of air in the atmosphere to ride it up like an elevator, and they go to the top of the thermal, and then they'll soar down to the next one. So a lot of people see circling vultures and often think, oh, there must be something dead on the ground, but really they're just taking advantage of the free ride to gain altitude to then move. So some birds like this can move hundreds of miles without ever having to flap their wings. It's a pretty efficient and incredible way to migrate. So raptors take advantage of this daytime thermal network. Songbirds just power through and spend a lot of energy flying to get through the night. Next slide. In more mountainous regions, you will get kind of clusters or bottlenecks of migrants. And so mountainous regions can be kind of higher danger zones and just a denser migrant path than other places. Like the Piedmont, you don't get quite as many birds funneling through there in big numbers, but you get up to the ridges of the Appalachians and you have a lot of birds moving through because they take advantage of wind sources to help power their flight. So this is called convergent lifting. Wind moves across a landscape, hits a mountain and goes up. And again, they use it like a free elevator ride or a tailwind. So you'll see a lot of birds there, but raptors often take advantage of this. And a great place to see this in South Carolina is Caesar's Head State Park. It's in the upstate. It's a lovely lookout, and tons of raptors move through during peak migration days. So very fun and exciting to go watch. Next. So we talked about raptors during the day. Now we're going to talk about songbirds at night. A fun little fact about this slide specifically, if you look either during September and October on a full moon and it's a clear night and you have some north winds, if you watch the moon through your binoculars, sometimes you can see birds moving across, like the little silhouettes of them flying through the night. So that's kind of fun. It's called moon watching. Next slide. So birds migrate through the night using a number of different tactics, depending on the species. Some of them use celestial cues. They'll look at different constellations, those were I was looking for, constellations and planets and things like that to orient themselves in the right direction. And they've actually tested this by putting migratory birds in a planetarium and showing them the right constellations to see if they change their orientation depending on what time of year it was. Pretty cool. Next slide. They'll also use the sun's position. When the sun sets and rises, an hour before and after sunrise and sunset, there is a beam of polarized light that shoots up from the horizon that birds are able to see. And so they're able to orient themselves and figure out where they are based on the sun's position at sunrise and sunset. And a lot of birds will actually experience what's called Zuganru. It's a fun new word you can use at cocktail parties to impress people. But Zuganru means nighttime migration restlessness. And so when birds know it's going to be time to move and you got to migrate, conditions are right, it's the right time of year. Around this time when they're seeing the sun setting and rising is when they kind of get that restlessness to get moving. Next slide. So I mentioned the polarized light at sunrise and sunset, so that's a big part of it. Next slide. They also have geomagnetic receptors in their eyes, almost built in like a rod or a cone in our eyes, where they can actually see and sense the Earth's magnetic field and the lines of the magnetic field on the ground. So following it almost like a roadmap. So they can see and sense even more than we can, which is pretty incredible because I get lost sometimes going to the office if I'm not paying attention. But these guys can migrate thousands of miles and come back to the exact same spot a year later. It's mind-boggling. All right, next slide. So when birds are migrating, depending on the species, a lot of them take really long flights. And to be able to do that, they have to stop and refuel and eat a whole bunch, gain some weight, put on some fat, and then they take off flying again. And one of the really good examples of this are red knots and horseshoe crabs. Horseshoe crabs spawn, they lay eggs in the sand during certain times of year. The red knot migration is timed with that so that they show up just as that spawning is happening so they can eat a bunch of horseshoe crab eggs, refuel, and then head back up to the Arctic or heading to, South America, the other pole, for wintering season. So red knots are a really important bird we pay attention to. They've declined a lot. And so this is one bird we really try and help out. Next slide. A lot of songbirds use native plants to refuel themselves. So when they have good stopover habitat, it's usually full of native plants. And in the fall, there's a lot of berries like this berry here is beautyberry. It's a great landscaping plant. Pokeweed, different dogwood is a really good one too. Magnolia fruits. A lot of that stuff is timed with their fall migration. So if you want to help migrating birds, plant native plants in your yard and try and protect areas in your community that might be good stopover habitat. Next slide. So you can see that this little thrush is eating, I believe that might be spice bush. Well, I should have looked that up, but that's not a plant I have in my yard, so I'm not as familiar with it. But energy-rich berries can make the difference of getting to your final destination or not. And we'll talk a little bit more about what happens when it's or not in a few minutes. Next slide. So some of the migration champions, the really cool big number, impressive stats. One is a bar-tailed godwit, and this bird broke its own record, and I had to update the numbers on the slide. This species has, excuse me, been documented at flying 8,425 miles nonstop in one flight without landing. They use satellite or cell tags to track these birds, and this one flew all the way across the Pacific Ocean in one shot. 11 straight days without landing. I can't even try and compare that to a human feat. It's not possible. While they're making these long flights, if they don't have enough food stored up from those stopover locations like the red knots and the horseshoe crabs, as soon as they go through their fat stores, they start to digest their own muscles and brain tissue and organs, and they just get skinnier and skinnier and make it or not. So pretty impressive. Next one. The longest round trip annually would be the Arctic tern. So Arctic, they go pole to pole. They do out 44,000 miles round trip annually. And in the lifetime of a good, well-lived bird, about 30 years old for an Arctic tern, they can travel 1.5 million miles, which is insane. And that's about the distance, I think, to the moon and back. So they call them the moon bird, which is pretty fun. All right, next one. The highest flight ever recorded was from a Rappel's griffon vulture, and he was documented at 40,000 feet of altitude. And you think, wow, how did you figure that out? Or how did they find out that that was that bird? Unfortunately, it got sucked into a jet engine, and so they took the remains of what was left of that bird, did genetic testing, and found out at that altitude when they hit that bird, that is what went through the jet engine. So a crummy way to figure it out, but a really impressive feat. Birds can go up that high. Next slide. Bar-tailed goose. Those guys will migrate over the peak of Mount Everest like on a regular basis. No big deal. Just 29,000 feet in a flock of birds. It's just incredible what they are capable of. And birds actually have a lot of different adaptations to help them store oxygen in their blood, have it, stay in even in low oxygen environments. The way that they breathe, they don't have just two regular lungs. They have a series of air sacs that constantly are moving air in and out. Even if you're exhaling, the bird still has air moving into another air sac. It's very complicated, but just know that they're well equipped for low oxygen environments and migrating at high altitudes like this. Next slide. All right, and then the snow goose, that's one of the more impressive migrations. They get into huge, huge groups. I think folks in the Midwest are probably more familiar and out west with this type of migration. We occasionally get snow geese showing up on the coast and in South Carolina, but not in numbers like this. So something really impressive to go see. Next slide. One of the perils that they face is the open ocean crossings. This is a short-eared owl, and it is currently pictured on my uncle's fishing boat. He was out in the Pacific Ocean in Alaska. This bird was disoriented and lost. Who knows what happened, but he ended up landing on his fishing boat and got taken to a rehab center. So next slide. So that bird did survive. They actually flew him down to his wintering grounds on a private flight. So he got to cheat during migration, but he made it. And it's, just goes to show what they go through and how dangerous migration is for birds. So dangerous that when they're flying over the Gulf of Mexico or big stretches of water or a storm takes them further out to sea than they anticipated, if they don't have enough energy to get back to land, they will fall in the water and into the belly of a shark many times. They were doing a study on sharks in the Gulf of Mexico, looking at stomach contents, and these are the different types of birds that they found inside shark bellies. And you can see during the time of year, it's very much keyed up with migration times. So pretty wild to think one of the predators of our backyard birds that we think of is a shark. All right, next slide. The other big thing is running into stuff in the dark. Birds have evolved with nothing else in the sky for millions of years until we came along and started putting up skyscrapers, guy wires, buildings, all those things. And so now, unfortunately, they end up getting disoriented. They run into things, not knowing that they're there. This is an imprint of a bird on a skyway bridge, so like a little walkway over a road that has glass on either side. This was more of a daytime collision, and that's a whole nother issue, but I want to show you what the impacts look like when a bird does hit the window. You'll see a faint outline, and that is actually created from a feather called powder down. It's a feather that breaks apart and is used for preening and keeping their feathers in good condition, but it makes a perfect silhouette and outline of a bird when they hit the window, which is really sad. Next slide. And so in 1 year, 365 to 988 million birds die annually from collisions, and that can include daytime collisions and nighttime collisions. Daytime collisions there's an issue with reflectivity in the glass. Birds don't see it, they run into it. But the rest of it is nocturnally when they're migrating at night. 56% of window collisions are low-rise buildings, so shorter buildings, not just skyscrapers. I mean, the skyscrapers do have a higher mortality rate because when the birds do run into them, it's usually a lot of them in one place. But as far as the full percentage goes, low-rise buildings is 56%, and then residential homes is 44%. So there's a lot of work that we can do in our communities and in our homes to help protect birds from running into the windows at night. And then, of course, skyscrapers have their own issues, but we can all make a difference. So I believe that is my last slide, and I think I'm going to hand it over to Jay next. Oh, nope, just kidding. Lights out is what we want to talk about, but the dead birds on this table are all from a one night on a building in Galveston, Texas. So it's pretty insane how much an impact, these buildings and light pollution can have on bird populations. All right. And with that, I think I am now handing it over to Jay. There you go.
Hey, thanks, Jennifer. Okay, my name is Jay Keck, and I'm the Industry Habitat Manager for the South Carolina Wildlife Federation. And, a bird changed my life. It was actually two birds, and one I think is favored. I think Jennifer said she likes the indigo bunting better than the Painted bunting, and I have to agree. I always am a little hesitant to admit that whenever I'm with some people in the coastal plain of South Carolina that have painted buntings. But that's one of the birds that changed my life and connected me to this amazing planet even deeper than I already was connected. As an outdoorsman, through hunting and fishing. I also wrote down the word Zuganru, and I'm not going to tell you how I spelled it, but I'll Google it afterwards because that is one of the coolest words ever. But yeah, today, even though I'm a bird guy, I'll talk about a couple birds, but I'm going to tell you how light pollution, or they call it Allen, artificial light at night, affects some of the other critters that are out there, and a lot of these other animals that I'll talk about, are some of the animals that feed our birds. So we'll go to the next slide, Savannah. And one thing that I learned is that there's a lot more research that needs to come out. This satellite imagery picture on the right-hand side, I think was taken around 2016. They found that whatever imagery that they were using really showed well the effects of light pollution all around the globe. And you can go to the website there, and there's a lot of things that I'll be talking about, and a lot of information, and I'll give you resources at the end of the webinar or in an email, so y'all can do some research for yourself, because there's just so much information. But information is continually coming in. You think about the first town, based on what I read, the first city was outfitted with LEDs. I think it was 2006, but even if it was in the year 2000, in geological times, I mean, that's a blink of an eye, right? So we're just starting to get a ton of this information in and learning more and more about it. One thing that I just, kind of wanted y'all to think about, I was born and raised in South Carolina. I used to sit on the south side of Lake Murray on our dock with my dad quite a bit, and we'd watch meteors. And one of my favorite things that we could see was the Milky Way. And I have two boys, one's 13 and one's 9, and we've never seen the Milky Way. And I live now on the north side of Lake Murray, and that's something that I don't get to experience with them. And that'll always be a memory that I have with my dad. So, I don't know, that makes me happy. And I'm just wondering, how many people aren't, able to experience that right now with friends and family, or just themselves. Think about Van Gogh. Would we have Starry Night, one of his most famous paintings, if he was born in the 2000s, or in the 1980s or so? So just something to kind of think about. And, NOAA did give me a second, National Oceanic and Atmospheric Administration did a study, and they estimated that 80% of Americans will not be able to see or cannot see the Milky Way due to light pollution. And they estimate around a third of the global population can't see the Milky Way. So just, from an inspirational standpoint and creativity, think about all the creativity and inspiration that's not happening because of the night sky that we cannot see anymore. You can go to the next one. So, based on the research that I did, it seems there's a few effects of artificial light on wildlife. And this comes from the Florida Fish and Wildlife Conservation Commission. Light attracts organisms, and that can be bad. It can, increase predation upon those animals. It can exhaust them, and we'll talk about that a little bit more. But it repels some animals. We'll talk about the large predatory cats a little bit, some bat species, even birds like whippoorwills that try to avoid as best as they can artificial light as they migrate. And then finally, it alters the day and night patterns. They might not get enough sleep. It can alter reproductive cycles, and melatonin is a powerful thing that we produce, and if we're not producing it at night, our body can't oftentimes repair itself the way it should. And I just love these pictures here. And think about the animals, the organisms that are being affected by artificial light at night. Think about the beetles and the moths and the damselflies and dragonflies, and they're eaten by frogs. They're eaten by other things too. And then you've got this beautiful green heron that's eating a green tree frog. And then that green heron, I don't know if it's going to be predated upon by another bird, maybe. It'd have to be a big one, but you know, the juveniles and the young, you know, they're food for other animals. So, you know, it affects everything or so many organisms out there. Just kind of something that I want y'all to think about. All right, we can go to the next one. Another thing that I used to see as a child, I mean, I used to catch jars of these, and you know, you read about, you know, the decline, or at least the perceived decline of fireflies, and you read about, you know, folks saying the same thing. Grandparents catching, you know, and filling up jars with fireflies. You know, I'm 45 years old and I remember that, but that is definitely something that my kids have never had the opportunity to do. And they grow up in the same state, you know, about 10, 15 miles from where I grew up. You know, you think about, it's not just, you know, light pollution that's affecting them, but habitat loss, degradation, alteration, you know, to their landscape, pesticides, even native plants, you know, fireflies or lightning bugs, you know, they eat pollen, they eat nectar, sometimes they eat each other. And if we're, you know, installing plants, you know, from Japan and Asia and Australia because we think they look pretty, they might not be able to feed upon those. So just one more thing to think about as you're, you know, kind of developing your habitat and your yard. You know, are you doing it with nature's best interest in mind? But according to the Xerces Society, more than 3/4 of firefly species in the United States and Canada are nocturnal or crepuscular. So, you know, the effect of artificial light at night can be significant for these. And scientists have done studies that showed some of the fireflies, which they, you know, they illuminate to communicate, you know, the males oftentimes will fly and then pulse that light, and the female will be either on low vegetation or on the ground, and she'll respond, and then, you know, then they mate. Well, hopefully they do. And studies have shown that the males will either stop completely, you know, pulsing, or they will just slow down. They've also found that places, even with, you know, yellow or orange lights, can kind of drown out or wash out the yellowish kind of orange glow of that firefly, affecting their reproduction negatively. And again, I'll send a link to everybody so y'all can look into that a little bit deeper. We can go to the next one. I think this one's probably been studied the most, and it's a relatively easy concept to get. I just kind of imagine, you know, being alive 200 years ago and being at the ocean, and just imagine what you would see. You know, if it's even a half moon, or even no moon at all, you know, the Milky Way is going to be there on a clear night, at least, illuminating the sky. Some stars, some planets, you know, there's a little bit of light trickle that's going to come down, but you're also going to have that reflection from the ocean. So, you know, if I'm a baby turtle a couple hundred years ago that comes out and begins looking around, the brightest thing that he or she is going to see is going to be the ocean, right? Or the ocean side. They would stay away from the darker silhouetted, you know, dunes. So they knew that dark was not good, and they would go towards the light. Obviously now, you know, as this picture kind of illustrates, the ocean isn't the lightest thing anymore. So they'll, you know, become disoriented or orient themselves. They're thinking correctly to the brightest light, and they will, you know, cross roads and, you know, oftentimes die. The numbers, there's a large disparity between the numbers that I found. Some articles I read and some papers I read, you know, were supported 100,000 or hundreds of thousands of sea turtles would die because of this. And then I've read, you know, some articles that supported or suggested that millions of sea turtles would die. So I'm hoping that they'll polish up those numbers in the future. But I guess the point is that at least hundreds of thousands of these, you know, die every year because of light pollution. Go ahead, Samantha. Listen, I don't have any slides with, mentioning jets or, sharks or anything like this, but I do have the dung beetle. All right. And I think dung beetles are awesome. I did more research on dung beetles for this presentation than I ever have. And I'm glad I did though. That gorgeous rainbow scarab beetle that you see right there, that's one of those that we have right here in our own state. And I hope if you haven't found one, I hope you get out and take a closer look and find one of those. It's always a treat to come up on one of those jewels. And hopefully you're not alone when you do. That's not one of the ones that rolls the dung. That is a tunneler. I learned that there's 3 types of dung beetles. You've got a tunneler, so this one will go through the poo, the dung, and just tunnel right below it. They'll create these chambers and store their dung there to feed on or have their offspring feed on it. There are ones, I think, if I'm correct, they just lay their eggs right in it, and that's the way that they do it. They don't roll and they don't tunnel underneath. They just deposit their eggs right in it. And then you have the ones that actually, they're called travelers, the ones that roll the dung. And you can see on the graph or not the graph, but the illustration on the left-hand side, on a dark sky night, with no light pollution, you can see that, there's a central location where the dung is, and then they are able to use the Milky Way or the moon or, some of the constellations, like Jennifer was talking about earlier about birds, I think, to kind of orient themselves and guide them to their destination. And they're trying to get away from competition, other dung beetles, and they want to make sure that they get to bury that before that dung ball, dries up. They want that nice and moist, right? Um, Even in places where there is light pollution, as long as there are large, antennas and other structures with light, they've actually found that they can navigate, and roll that dung away from the central location. So it's still okay. I don't think it's optimal, but they still, I think it sounds like from what I've read, they still get the job done. The problem is when there is that really bad glow that we see. I mean, I'm in Chapin and I can see on the other side of Lake Murray to the south, where Lexington is. I can see where Newberry is, and they can see where Chapin is, even though we're a lot smaller. We've got the sky glow. And so that's, that glow is what really disorients them. They can't really see those structures. They can't see the celestial, things that are out there for them to navigate. And then, there's again, competition. They may not be able to bury it. It may dry out too quickly. And so it really messes them up. And when you're thinking about beetles, think about everything that eats them. And if they can't reproduce, as well as they could without light pollution, what else are they affecting? I love whippoorwills and I love chuck-will's widows. And if you read about them, I mean, their diet, listen, if I can, I'm going to get to this one. I want you to listen to how many beetles the eastern whippoorwill eats, but let's see, including moths, scarab beetles, click beetles, longhorn grasshoppers, stoneflies, ground beetles, carrion beetles, tiger moths, ants, bees, wasps, fireflies, longhorn beetles, measuring worm moths, owlet moths, weevils, and scavenger beetles. So, I don't think our warblers, as far as I know, are really going after the beetles, but things with really large mouths like our whippoorwills, chuck-will's widows, even purple martins will take those beetles. So shut the lights off or really reduce what you have, and create a log pile and a brush pile and give those beetles something to breed in and live under, for your birds on your property and everything else. All right, go ahead. This was totally new, but it makes a lot of sense. I just learned it, in my research, but habitat loss, it creates habitat loss. So if I'm a little brown bat and I don't want to be predated upon by owls or other birds of prey that kind of like to hang out at artificial light sources, during the evening or at night, if I'm not going to fly through there, I just lost some of my habitat. So, the habitat shrinks. I have to potentially work harder for my food, if I can find it. So I just thought that was an interesting idea. I read an article from the National Wildlife Federation that suggested that large cat predators do try to avoid as best as they can those areas with lights. And then you think back to the whippoorwill flying, and this was a paper from a PhD student at the University of Manitoba, I believe, from Canada. They put GPS devices on male whippoorwills and followed them down, and they just saw this meandering pattern of their migration. And the data kind of suggested that they were avoiding, cities with too much artificial light, at night. So, it's a form of habitat loss, and that's a large scale habitat loss, and think about the extra miles that those birds might have to navigate in order to go around those cities with the bad light problem. Go ahead. I thought this was really cool. There's a few ways that these insects, and real fast, when we're talking about insects, there's a paper back in 2018, I believe, that suggested that 400 to 500 million tons of insects are eaten every year by birds. I think spiders outdo them by maybe 100 or 200 million tons, globally. But when we're talking about insects, I think Jennifer had mentioned that, 90% or more of our terrestrial, birds eat insects. The data, from that paper really supports that. Think about the thousands, the millions of tons that are being consumed by birds. So when we have these insects, gathering around these lights and they're exhausting themselves, or they just crash and pass away, or they're just not fulfilling their ecological, action or need, of breeding, finding food, foraging, it can really harm, not just our birds, but wildlife in general. They are eaten by, so many different types of species out there. But I thought this was kind of cool. Like say if this was a light, and I am a moth and this is my back, I kind of orient my back around the light. Like if I was doing it like the picture suggests, or illustrates, that's called orbiting. But there's also a way in which they kind of, stay around the light, and that's called stalling, where they'll be flying, they see the light, and then they kind of invert a little bit, and then they just kind of go up, and then they just kind of stall out. And I didn't really see too much information after that. So I'm assuming that they just repetitively do that. And then there's inverting, where they're flying, they pass the light, they invert to keep their back, to the light, and then they just go straight down, and then they crash. Oftentimes, they crash and then they die. The idea is, the reason they do that is, historically, before artificial light, they would keep their back to the moon, the stars, the Milky Way, that light. And so they could just kind of fly nice and level, as they kept that, to their back, and they knew that the earth was, below them. So that's the best explanation that I found as to why. And that was a study that was done just recently in the last 2 or 3 years, and I'll have that link for y'all too. But that was the best explanation as to why insects do that. And we'll go to the next one. I'm not going to spend too much time on this. Y'all can see the effects of the direct effects and the indirect effects of artificial light on insects, whether that's an adult, a larva, or even the pupa. And I'll again have the link for this, but direct effects: activity suppressed, feeding suppressed, distracted, by the light, so wasting a lot of time probably and not doing what they're supposed to be doing. Direct mortality, that when they invert and they crash down, oftentimes it's fatal. Population fragmentation, again, habitat loss. Copulation reduced, feeding suppressed again for the larva, and then reduced body mass I've found evidence of. And then, the study on the right-hand side at the bottom, suggesting that 60% of invertebrates are nocturnal, and then including 75 to 85% of our moths and butterflies. So it can affect a significant amount of our insects. All right, go ahead. And I never thought that that this was a thing until I started researching, but you can see directly the effects of artificial light on plants. And you can see that, I don't know if that's a sumac or not, but it looks like it to me. It could be something else. But you can see where it's turning red, and then you can see where the light is, and the leaves are green. So the idea that scientists have that affect insects negatively is that there could be caterpillars, leaf miners, which are little teeny caterpillars, other insects that are staying on these leaves way too long. Then winter rolls in, they're still on there. They haven't done their seasonal duties, and there could be a lot of mortality there. It increases predation also. And there's all sorts of negative effects with streetlights on the actual plants that also affects the insects that predate or use them. So go ahead. And listen, I'd like to be healthier. I'm 45. I would love to be the healthiest, JCAC as possible. And we're living in a world where it makes that really, really, tough. And this is just one that I've really never thought of, before the last, few years of beginning to learn about this and listening to podcasts. And I'm just going to read some of the things that it can lead to, but sleep deprivation, stress, anxiety, fatigue. Says suppressing melatonin, which is known to be a powerful antioxidant, is thought to lead to cellular damage and some cancers. When we disrupt our circadian rhythm, it can increase our obesity, diabetes, and mood disorders. So, please do your own research. Listen to a good podcast, read, and I don't know, let's help wildlife out, but I think we can really help ourselves out too. And then next slide is my last one, I believe. I've gone to Costa Rica 4 times in the last couple of years. And every time I come back, my wife, if I didn't go with her, my wife, tells me that I need to stop, being in my Costa Rica chill. And listen, I just came from a beautiful place, so I'm all happy. But I would say one of the things why I'm so relaxed is that I go to sleep at night when I'm supposed to. Yeah, I'm tired from hiking and looking for snakes and birds and everything. But, the places that I've always stayed at have limited, if any, artificial lights at night. And I remember taking a group down there, and at 7:30, people are ready to go to bed. They think it's 9:30. And we wake up and we're birding at 5:40 a.m. The clay-colored thrush wakes us up, and the howler monkeys wake us up. And I don't hear anybody complaining about how tired they are. There's no TVs, there's no tablets out. And this green honey creeper right here was taken by my wife's cousin as we were watching, green honey creepers and shining honey creepers and red-legged honey creepers, feed at all these birds at dusk, or I'm sorry, all these insects at dusk by this one pond with fallen trees in it. And the number of insects and the number of birds was just remarkable, and there was no artificial light. And listen, is that anecdotal? Yep, absolutely. But it happened. And I can only tell you how I feel, when I'm down there, and how quickly I don't feel like that whenever I get back up here. I've got my kids, I've got a job, and I'm doing other things too. But boys, there are a lot of light and a lot of other things going on here that negatively affect, in my opinion, wildlife and us. So I appreciate you listening to me, and I'm going to go ahead and hand it off to Amy.
Thanks. I'm Amy Tegler. I'm the Bird Conservation Coordinator for the South Carolina Department of Natural Resources. I guess, I would second everything Jay and Jen said about their love of birds. I often get asked, what is your favorite bird? So I've spent a lot of time thinking about that. And my genuine, honest answer is that I like them all. Like, it's really the one I'm looking at, the one I can hear, the one that's in my hand at the moment. I can't decide. And I was also thinking, as I was listening to them talk, about my experiences with birds. And I would say that one of my most striking personal experiences that I've had was early in my career. I was working along the Gulf Coast during spring migration, and just going out to the beach and seeing the birds fly over the Gulf of Mexico and just being so exhausted. Like they would literally just fall down to the sand once they got to the land. And it was just really striking to me, the effort these birds have to take, for their migratory journeys. That's an experience I'll never forget. So anyway, I want to dig right in so we don't waste too much time. So I'm going to go through some strategies that we can all do to help reduce light pollution. And so we'll send out links through all this, so don't worry about taking notes as I'm going through. So what can each of us actually do to help reduce light pollution? Next. So these days, artificial light, it's all around us. So I want to start out by explaining what exactly light pollution actually is. Light pollution is essentially misused and wasted light. It's caused by inefficient and poorly designed light fixtures, and also leaving lights on unnecessarily. Some of the consequences of light pollution are glare, spill light, overlighting, and sky glow. The image on the right shows an example of spill light. It's light from a source into unintended areas. It's most often noticed when it comes into like your neighbor's window or onto another property. Next. Glare is bright light that results in reduced visibility. It's often caused by horizontal light. The top picture shows examples of a light fixture with a design that creates glare on the right, and a design without glare on the left. And that's because it directs the light downwards. One result of glare is night blindness, actually. The two photos at the bottom show how visibility can actually increase when light fixtures are designed appropriately and glare isn't present. Next. Overlighting and sky glow are probably what most people actually think about when they hear light pollution. Overlighting is illumination that is brighter than what is required for humans to see. And sky glow is the illumination of the sky often seen above cities. Bigger cities tend to produce more artificial light, so that's what people tend to think about. But small towns are actually also can have quite a substantial impact to migratory birds, because those areas tend to be closer to the wildlife habitat. I actually took this photo a few weeks ago in an airplane, and it just really struck me. If I was a bird flying through the sky and I didn't understand what artificial light was, or really what a star is either, I could see how this could be really confusing, and how a bird can be disoriented when they see something like that. Next. So light pollution comes from both residential and non-residential areas. Some widespread sources of light pollution include interior lights, exterior security lighting, landscape lighting, and vanity and architectural lights. Non-residential light sources include things like advertising fixtures, street lights, lights at sporting facilities, parking lots, and also sometimes festival lighting. Next. So sometimes people think that light pollution is just this big problem, and it's not, and there's not really anything that they can do individually to help. So I'm going to go through a few things, because there actually are things that everybody can do, even at their own house. So for interior lighting, you can reduce light spill from your windows by turning off interior lights when they aren't being used. And of course, this can be done manually, but there's also things like timers that can be done to automatically turn lights off. For the interior lights that need to be on, just simply close your curtains, your blinds, or your shades, and that also helps reduce the light pollution. Next. So there are also several things that can be done to reduce artificial light pollution for exterior lights. One of the best things is to use light fixtures that direct light downwards. And in the top image, you can see how different light fixture styles can impact where the light actually goes. All the light going upward is essentially unnecessarily wasted light, even the horizontal light. An added bonus is that downward directed light, like what's labeled best in this top image, also reduces glare and can also increase visibility. Lighting should also be placed as low to the ground as possible. And it should be only placed in areas where it's actually needed, for the light, with the light being directed only in the specific areas. The bottom picture, for example, shows an example where lighting was placed near the ground and only illuminating the walkway. And it doesn't necessarily illuminate the sky. And even the lights higher, a little further away into the walkway, are down shielded because of the ceiling. Next. So here are some examples of what down shielded lighting fixtures actually look like. On the left are ineffective light fixtures, or are the bird-friendly light fixtures, and on the right are the ineffective light fixtures. And if you're trying to figure out, going back at the store, trying to figure out which light fixtures are effective and to buy, you can look to see if they're dark sky certified. And that's one way to help figure that out. So I'll give you a few seconds to look at this. So many exterior lights are for security purposes. But I just wanted to do a quick note that security lighting must be carefully designed to be effective. Increased lighting does not necessarily result in greater security, and that's due to the glare that I mentioned, and also blind spots from shadows that can be created. All right, next. The color of the light can also affect birds and other wildlife. Warmer colored lights, the amber or reddish tints, are less harmful to birds, while the blue and the white shaded lights tend to have a greater negative impact because it's more likely obscures the stars, like they had talked about before, that are used for navigation. When you buy lights, bulbs that are less than 3,000 kelvins, like on the label, are the warmer tones. And nowadays, LEDs are effective at projecting light across that whole color spectrum. And also, lights should also be as dim as possible. They only need to be bright enough for people to see. Anything brighter than that is essentially just wasted light. Next. One of the most impactful things that a person can do is to only use exterior lights when they're needed. It is especially important to reduce exterior lights during spring and fall when birds are migrating. Ideally, exterior lights would be turned off from March through May and August through October, from 10 p.m. to 6 a.m., while birds are more likely to be migrating through the night sky. At a minimum, turn off lights on cloudy nights during those periods because the clouds diffuse the lighting, kind of making the lighting situation worse. If lights can't be turned off, one of the easiest ways to reduce the impacts of artificial light is to use lights with motion sensors. Another option is the timers. If lights need to be turned on most of the time, you can set timers so that the lights turn off for maybe like every 30-minute periods throughout the night. These breaks in light actually give birds an opportunity to reorient themselves and return to their normal migratory behavior. And using motion sensors essentially do the same, result in the same as setting a timer like that. The image on the right kind of summarizes the tactics that I've gone over. Ideally, lights would be turned off, only have them on when they need to be on. Use a down shielded light fixture with dim, warm tone light when they do need to be on. Lights should also be placed so that they illuminate only the areas that are needed. And in addition to helping birds and other wildlife, these changes can also actually help lower your energy bill. So added bonus for people as well. Next. And some of you may have opportunities to reduce artificial light in non-residential buildings. So I'll just quickly go over some of this. All of the things I've already mentioned still apply. Some non-residential areas might have lighting on clock faces, gardens, lobbies, atria, advertising, where the strategies to turn off, dim, and downshield can be applied. Some other strategies, if possible, restrict use of buildings to daylight hours. Interior lights that must be on, it's better to use task lighting at workstations instead of the ceiling lights to help minimize the light spill. When rooms aren't being used, turn off interior lighting, especially if it's higher than the 3rd floor. And also some non-residential areas use spotlights, and as best you can, try to avoid using those during the migratory seasons. All right, the next. So I'm guessing that, as I've ran through those, you're kind of thinking about the lighting that you have in your life. And so I put together a few questions that you can ask yourself. Does the light have a purpose that I need? Is the light illuminating only the area where it's actually needed? Does the light really need to be that bright for its intended purpose? And when do I really need to have the light turned on? If it needs to be on, what can I do to reduce its light pollution? Like I said, we'll send out links to all this information. And so now I'll hand it back to Jen for some closing remarks.
All right. Thank you very much. We do have a couple resources here on the screen, but it's really tough to copy down long links like that very quickly. So like Amy said, we're going to send out a bigger resource list and some other information and articles after the webinar. And we'll also have this recorded. So if folks couldn't make it to the actual webinar, they can watch it again, or you can send it to your friends. If you have someone in your life with really obnoxious lights, you can hopefully convince them about, getting IDA recommended lighting. There's also local folks from the International Dark Sky Association, Starry Skies South. They have great information as well too, and also host neat like planet and star watching events as well. So if you also want to try and do something more than just at your own home or your business or community, one thing you can do is advocate for dark skies and lights out. And you could do that with your local municipality, your city, your county, and try and do a dark sky week. The local Charleston Audubon chapter and Starry Skies South worked together to do that last year during spring migration. And that's something you could do in your own town. There's resources on the Audubon's website about that, and we'll send that as well. So if you want to get a dark sky ordinance, resolution, or proclamation locally, there's a lot of kind of pre-baked stuff that's real easy to adapt to your situation. And I think right now we're ready for any questions. If anyone has any questions, you can type it in the Q&A box. And if not, we will just, I guess, call it. Let's see. I don't think I see any questions coming in. Oh, looks like, oh, thank you, Bill. Appreciate it. He said, great presentation. Thanks for doing this.
And just real quick, I think if it's the same Bill, he started talking to me about this a few years ago. So, the folks that are going, to their cities and towns to try to convince them to do something, just stay on top of them. I just kept on telling Bill to remind me every single year. We've got so many things that we're trying to do: invasive species, native plants, putting up cavity box, nesting boxes for birds. I mean, all sorts of things. And this was new for me. So I just looked at the first email that he sent me, and it was back in 2021. And so appreciate him being patient. And we're just now starting to really talk about this as an organization. So I appreciate you all, but just be patient and keep at it, and hopefully we'll get results throughout the entire state and then beyond.
I did want to mention that the local IDA branch is the Starry Skies South, and you can find them on Facebook.
Awesome.
All right. I think that's it. All right. Thank you, everyone.
All right. Thanks, Jennifer. Bye, Amy. Bye, Savannah.
Thank you all.
Mm-hmm.